I'd like to introduce Ken Sprankle, project leader, U.S. Fish and Wildlife on Diadromous Fish.
Well, thank you very much for the invitation to present today. And I'm looking forward to sharing some information with you. Let me share my screen.
That's working. It's good.
Okay, perfect. Okay. Okay, hi. So thanks again for the invitation. My name is Ken Sprankle. I'm a fisheries biologist for the U.S. Fish and Wildlife Service. I've been a state and federal biologist since 1994. Over my whole career, I've always worked on migratory fish restoration. I've worked with a lot of other species. I've worked all throughout New England, and I'm happy to talk about all kinds of things. But the talk today is going to be focused about my current position, where I'm a project leader for a small office. I have one biologist that works with me, and I hire seasonals as well to work primarily on migratory fish restoration, diadromous fish species. Okay. Okay. And I'm seeing people on the side. You're not, the slide is not covered by anything right now. You can see the full slide?
Yes.
Okay,
yes.
perfect.
Correct.
Okay, I have a couple different images here. Okay, so the Connecticut River, largest river basin in New England, as folks know. There are over 3,000 dams that have been identified in the basin. Just a tremendous number of barriers that were built since the time of first settlement. Now, on this particular slide, I'm showing some major hydroelectric projects and dams. The first star is Holyoke Dam. That's the first main stem barrier on the Connecticut River. That's of obvious importance to us when we're talking about migratory fish. And I'm going to talk some more about that site and project. The other locations shown on the slide, the next star, I don't know if you can see my indicator or not. Is that showing on the slide?
Your mouse is, yes.
Yeah, okay, perfect. So that next star would be the Turner's Falls Dam, which folks are familiar with. Going up from there, we have the Northfield Mountain Pump Storage Project, which is not a dam, but it is a large hydroelectric project with serious implications to the work we're trying to achieve. Next, we have Vernon Dam up in Vernon, of course, Vermont and New Hampshire. There's the Bellows Falls Dam and the Wilder Dam. And I have all those projects on there because they're all under the federal relicensing process that we're in right now. We started work on that in 2013, whether you can believe that or not. We've spent years and we're not done. We're in confidential negotiations at the point right now. We're coming to the tail end. It's a tremendous amount of work that involves a lot of people. We're hopeful, obviously, we're going to get some important gains and benefits for the resources. Other people are looking to get gains and benefits for recreational uses and many other things. Now, that's not my concern for my profession and my duties. We're focused more on the fish, the fish and wildlife populations and habitat. Okay, let me get on to the next slide. Okay, so diadromous fishes. Here are the suite of species of diadromous fishes. I know Alex, who I work with regularly, gave a great presentation yesterday. American eel are the only catadromous fish, which is a really neat one because they're going out to the ocean to spawn. All the other fish we have on this slide and occurred here are anadromous fish otherwise that are coming into fresh water to spawn. So the American eel is the only odd one on that. You can see we have blueback herring, alewife. When people say river herring, that's what they're referring to. It's collectively those two species. And the Connecticut River is predominantly a blueback herring run. I do a lot of work with river herring. I'll talk a little bit about that. Striped bass and white perch are anadromous fish. Striped bass don't spawn. The spawning populations for striped bass, actually, it's Hudson River, and then you jump up to the Kennebec River in Maine. So they just come in here to feed in great numbers. Other species, sea lamprey, he had talked about. Short-nosed sturgeon, our only federally endangered species are short-nosed sturgeon, where we have a resident population, and they do migrate along the coast, and Atlantic sturgeon, which excitingly, we just, in the state of Connecticut with their monitoring programs, documented juvenile production in the lower river for the first time ever. That happened 2 years ago now, so that's very exciting. And I'm going to talk some more about American shad because I know Alex talked about sea lamprey and eels quite a bit. So American shad here, this chart shows some of the timings for migrations, which is of obvious importance biologically, that's tied with life history events. So sea lamprey, he talked about them coming in the spring, spawning, and then those juveniles developing over a period of 4, 5, 6 years before they out migrate. I know he covered that stuff. For American shad, for those of you not so familiar with American shad, that's a very important commercial and recreational species. John McPhee wrote a book describing how if you go back to revolutionary times and even before that when the Native Americans were here, that is the abundant food source. We were trying to restore Atlantic salmon, for example. That's a sport fish. They were present. But when you talk about sheer numbers and value in terms of food and what's coming to the river and size of fish, American shad are that species. And so they arrive in the spring. Those fish come back. They are typically age 4, 5, 6 years old. Males return before females because they mature a little earlier in life. And so they're showing up April, May, and June. I'm going to show some data on that. They spawn repeatedly. So a female will have on average about 300,000 eggs, and she'll spawn those eggs about 5 or 6 times over a period of every 3 or 4 days. And I've been involved with some radio tagging studies. This is pretty interesting work where the fish that enter the river, they're not feeding. And that's true for American shad. It's true for alewife, blueback herring. Many of these species, when they enter the river to spawn, they're not feeding. So they're living on stored energy reserves. That means they only have so much time to get in, spawn, and we want them to get back out to the ocean because all of those species can survive spawning. And it's important to have those fish survive spawning because that's how these populations have evolved, that it's not just first-time spawners, there's repeat spawners. And in the case of American shad, instead of having 30 or 50% repeat spawners, we're down in the 3 to 5% range right now. We're very concerned about that, obviously. And I want to keep going. I'm watching my time here. So how do we manage and try and restore these species? We do this at several different levels. Of course, there's the state level where the state regulations and the state law enforcement people exist. But when you're talking about migratory fish in the Connecticut River, that next level up, you need to do it on a basin-wide level. People can't be working independently. And so we have the Connecticut River Atlantic Salmon Commission, which was actually, as you can see in the slide, it began in 1967. It was called the Policy Committee for the Connecticut River. And the state and federal agencies, including Fish and Wildlife Service and all those agencies you see there, agreed to work on restoring migratory fish back in 1967. That was the year I was born, which is kind of interesting and to me. And then in 1983, that was transitioned into the Connecticut River Atlantic Salmon Commission. They said, hey, let's try and get federal recognition for this. So although it's called the Atlantic Salmon Commission in 1983, we've always worked on the other migratory fish species. But the salmon obviously took a lot of time and energy. So there's the commissioner level. Those are the agency directors, the head of my Northeast region, the head of Massachusetts Fish and Wildlife. Those are the people that say, okay, we'll put some money to this. And they take direction from us, people like myself and other senior biologists in the field. We're the state and federal technical committee members that develop the plans, do the data analysis, provide them information and say, hey, these are our recommendations when they ask us questions. And so that's how that group works, and it works really well. They're public open meetings. I'll talk a little bit more about that, but people can attend, and there's information on my website. So an example of one thing we've done with CRASC is this took a lot of work. We updated our Connecticut River American Shad Management Plan. That was done in 2017. We have population targets. It's based upon habitat distribution throughout the basin. You can see the figure to the right. Most importantly, we said how we wanted to develop fish passage performance criteria with the Ferc relicensings that are going on. And that took time to develop. We wanted to have data. We had modeling done. It was a lot of work. And that was approved in 2020. That went out to public comment. The power companies were not happy with us proposing fish passage performance criteria that we felt was absolutely necessary to achieve. And that is on my website. You can review it. It's a very large document. It's got all the questions they had raised, all of our responses. That's been submitted to Ferc, and it's a comprehensive plan. And we're citing that in our development of fish passage performance criteria and dealing with these power companies going forward. It deals not only with upstream passage for adults, but as I said, downstream passage for adults, which has not been effectively dealt with and very important to us, and for juvenile passage as well. Okay, so the other group, another level, is the Atlantic States Marine Fisheries Commission. So you can see since 1942, the Atlantic states have worked on managing. There's been a growing number of species. I serve on the American Shad and River Herring Technical Committee. So we've got every single state from Florida to Maine, we have membership on that. So it's a big technical committee. I'm the Fish and Wildlife Service representative, and there's a National Marine Fisheries Service representative. We just did a really big effort to do a coast-wide stock assessment. You see the report there. It's on the website. It's over 1,000 pages. It took us 1.5 years or 2 years to do. It was really good science, very good information. So that's really just done to help us inform our management and restoration. States cannot propose to do, a state can't say, oh, we're going to open up a commercial season on river herring or American shad, and we'll have 10 fish. They can't do that. It has to go through the Atlantic States Marine Fisheries Commission. So that's the way these species are managed because they're migratory. And so as that technical committee, we review all these plans and proposals and develop criteria. And so it's done in a very coordinated manner using the best science and information. I think it's a really good system. Some of the things that I'm involved with other people, the things that I do in my office, I spend about 1/3 of my time doing population assessment work. That's status and trends. I do a lot of river herring population assessment work. We're out doing juvenile shad assessment work right now in the evenings. The technical committee work, I spend about 1/3 of my time on that. That's at the CRASC level, the ASMFC level. There's other committees and work, so that takes about 1/3 of my time. And 1/3 of my time is dealing with hydropower, the relicensings that are going on all those projects, and dealing with Holyoke. Holyoke, we are continually working with. The thing is, you can't, there's just not an example where I can say we've done something and walked away. It's always an ongoing process in terms of evaluation, tweaking, improving things. And I'll talk some more about what's happened at Holyoke. I also work with fish habitat and restoration. We do some smaller scale projects, population restoration. We do some fish transfers, the coordination with the companies, research. I do that with the Conti Lab. So that's like with Alex Harrow, for example. This year, we did a really great, important study. We were down the lower river tagging, surgically tagging blueback herring to find out where these fish go, because I've been doing a lot of population assessment work, but without the tagging, you're missing some key information. So we're really excited about that. And so we've just downloaded all of our receivers, and we've got lots of good data to look at. For outreach, I have Fishway count reports. If people want to be updated on what's going on for Fishway count reports, I do that. I have an email list with 200 something people on it. And in the spring, I'm sending out updates on how many fish are passing at the Fishways. And you can go to my website and you can see the reports there. So here's some data we could talk about quickly. American shad numbers, you can see how those have varied over time. We average about 300,000 shad a year. You can see this year was a down year, unfortunately. The blueback herring, that should catch your attention. That's very troubling, right? It's very troubling to us. And that's why we're spending a lot of time trying to figure out what's going on. But it's not just about numbers. As the slide shows, stock structure is a concern. What's very important from a management standpoint is the age structure, the repeat spawner component. There's a lot more that goes into proper management of these species than just simply a numbers game. Okay, and here's some data. Dramatic declines along the northeast. Basically, all these migratory fish are in trouble. I gave you some good news on the short-nosed sturgeon. Those numbers have been increasing in the Connecticut River. That's good. In Atlantic sturgeon, we did have some good news on that. So, but you can see what's happening with river herring and American shad just since 1950. Not a good situation. Troubling. Here's the first dam. at Holyoke. And one of the things I want to point out here is we have a fish lift system there that was installed in 1976 that works, we feel, quite well. And the figure that's included on there shows you the relationship in the spring to this year, for an example, with river flow, because we expect these fish, when they come up the river, to find an entrance that is 6 feet wide, that has a couple hundred CFS, as opposed to tens of thousands of CFS. This is what Alex Harrell and the Conti Lab and our fish passage engineers, we really struggle with. We need to attract fish to these fishway entrances so they can use them. And so you can see in the figure there in the yellow, when we have very high spring flows, this year it was very late. It had nothing to do with snow melt. And you could see in early May, the river, there's just water spilling over that dam. There's no way for the fish to find these fishway entrances. And that's why in the green, you see no shad being passed. As the fishway levels drop down below 20,000 CFS and the river gets more under control, that's when the shad can begin to find these entrances. And you can see that relationship of how those flows decreased and how we pass shad. And that reflects, that's kind of what shad passage looks like in the spring for adults. It's basically, it should start early May. They have come at the fish lift, pick them up as early as mid-April. But it's a function of what's going on for them to be able to attract. If you were in the lower river just setting gill nets, they're there in early April. And with the radio tagging study, you folks would find this interesting. We found that about 75% of the fish that enter the river go up to the Holyoke Dam. And of those fish, about 75% of those fish successfully pass the dam. So basically we're passing in the neighborhood of 60% of the run upstream of Holyoke. And that was pretty interesting to learn and find out. And this is what the fish lift system looks like. The fish, most importantly, have to be attracted and get into the entrance. And once they're in the entrance system, there's a crowder gate that will crowd the fish up to a bucket. And then that bucket is lifted. I have no idea who's been able to go down to Holyoke, but they've got a great public viewing opportunity down there. And it's really cool and great to go visit in the month of May. And they're operating right now, not for shad, because again, that's in the spring, but the short-nosed sturgeon, which I'll show some information in a minute. And I know I'm running over on time, which I apologize. Downstream passage is incredibly important to us. So it's adults and juveniles. We've got operational and engineered approaches. The things that we're concerned about are cumulative effects. We want to get these fish, in the case of American shad, blueback herring, these other species, all the way up to Bellows Falls Dam. So that means those fish have to go by Holyoke, they have to go by Turner's Falls, they have to go by Northfield Mountain Pump Storage, they have to go by Vernon Dam. Now, if you take a 10% loss at each one of those, you've lost way too many fish, completely unacceptable to us. And that gets into our fish passage performance criteria. Cumulative effects are very important to us, not just for mortality, but injury, and very importantly, delay. I mentioned these fish are moving on stored energy reserves. They only have so much time. So delay becomes very important. And delay is what I have just been talking about. When there's water spilling over the dam, can they find the entrances? So this is where it becomes complicated. You need fish passage engineers. You need the Conti laboratory working with us. And these are the things that we have learned a lot, and we have some good advances. And examples of that include short-nosed sturgeon, where we modified the entrance at Holyoke. Again, engineered some new solutions with some better science. And you can see what happened in 2016. That's when the new designs went into effect. Boom, look at all those sturgeon. Really exciting. And it's really tailed off. And this is all new information to us. So we don't know what it means. We've been tagging these fish, and we want to make sure those that get upstream can pass safely downstream. That's why they were not being passed up until that date, because we had to put a whole new protective downstream passage system in so that those fish would not be injured or killed. Okay, so I'll wrap it up that, basically we've got a lot of, this is the hydropower map. You can see we're lit up here in the Northeast. But the thing I want to close with is these Ferc licenses are for 30 to 50 years. It's a once in a lifetime opportunity. I've told you how we've got the 4 main stem projects upstream of Holyoke, and we have been working for years now on this. So we've got a great opportunity. We've got a lot of agency people working on this, good science, the Conti Lab's helping us. So I'm very hopeful that we're going to see some real improvements. And it's not just the Connecticut River. Throughout the Northeast and really along the East Coast, these licenses are all coming up. So the fish passage technologies and approaches we took 30 plus years ago, we can do much, much better. And so those terribly low numbers we see, I know we can get improvements on that. And so I'm really excited and eager to have that happen. And I think I'll just close with that. You can visit my website and I'm happy to try and answer questions. It's just, I don't know, there's just so much information and I apologize.
Ken, that was wonderful. I'm going to suggest a couple things. If you could type your website into the chat, that would be very helpful. And because we are running a little bit over, if people could type their questions to Ken in chat, if you don't mind answering back, or we'll put you in touch with people if that doesn't work out. Ken, that was wonderful. I'm going to suggest a couple things. If you could type your website into the chat, that would be very helpful. And because we are running a little bit over, if people could type their questions to Ken in chat, if you don't mind answering back, or we'll put you in touch with people if that doesn't work out. It would be good to move on. Our next presenter is,
thank you again.
Thank you so much. That was, I feel like it was a semester in 20 minutes.